It is 2:01 UTC on the 5th of March, 2018. Hey, everybody. This is Astronomy Daily Live. Do a live stream every single day where we spend about an hour or so coming together with friends and talking astronomy. Anything astronomical, getting into science, all that kind of good stuff. Yeah, so hope everybody's doing well today. Hope your past 23 hours was good. I was pretty much working all day on getting this new project of mine up and running. I need to Heather, Uncle Bill. I need to usually go through some preliminary steps in order to make sure that what I think I want to be doing, I can actually do, and that usually takes a lot of consideration in terms of is this even possible? Is is there some part of this thinking process that I'm going through now that says yes, go for it. There really are no obstacles, and yeah, that's sort of what I'm finding out about this project. So tonight's drink of choice again is the hydrogen hydroxide. Always an awesome, nice and relaxing chemical. So hope everybody's doing good. Let's talk astronomy for an hour or so. I can sort of, as I said, I'll get you updated on what I'm doing in terms of this new project I'm working on. It's uh, it's basically just uh, figuring out uh, ways to maximize the use of this scope and my camera. So this is a CCD camera. Now this is an older CCD camera, um, and it's sort of in two major parts. The front part, which my fingers are around, is what's called the filter wheel, and that's exactly what it is. Inside of this round part here uh, is a wheel that has, I think, five or six different uh, 1 inch diameter openings in which I can place these round filters. And filters uh, uh, are usually available from camera companies, astronomical camera companies, and there's lots of different kinds of filters. Some of them are um, 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 professional grade, like Johnson U, Johnson B, Johnson V, all of those. There are also filters that are basically like red, green, and blue. And I believe in this camera, I have red, green, and blue, and then a clear one. Might have a lunar one. Not exactly sure. I'll have to look. But anyway, this is what I'm working with. Can you see that? It's blurry, but you can probably see. It's kind of hard to see. Anyway, this is uh, an S-Big ST7E, and as you can see on the back, it's a parallel port. So this is an oldie but a goodie. This is a nice rugged camera. If I take care of it, which mainly means if I don't ever drop it, it'll run forever. And so I'll show you there's the little, yeah, we're not going to be able to see it because it's too bright in the background. But there is at least the filter that's in front of the CCD. Can't see the CCD itself because of all the reflections and whatnot. But there certainly is a CCD camera back there. The rest of this is just thermoelectric cooling. So I can drop this thing 30 to 40 degrees below ambient, which, in the summertime is sometimes only going to be 0 degrees C, but that's not too bad. That's not too bad. The whole point in trying to keep the electronics cool is to keep the noise at as low a level as you possibly can. But if you're doing the right thing, you're taking calibration data to sort of account for all the systematic errors like noise, like electronic noise in your data. So I have no problem operating this kind of thing all the time. So that's my baby toy, that one, and this scope behind me. And with that and a little bit of computing power, I am set. And so the system that I have can do two things right out of the box. The first thing is that it can do this thing called astrometry. And astrometry is just measuring the positions of objects in the sky as accurately and precisely as possible. And so that is one thing that I have the capabilities of doing, is collecting this data, this image data, and measuring the positions of either the stars or the objects, be it an asteroid or be it, whatever I want to look at, right? Measuring very, very accurately with high precision the positions of objects in the sky. So that's number one. That's astrometry. So it is the measure of the sky. Astrometry is the measure of the sky. So the other thing that I'm capable of right out of the box is this other form of measurement called photometry, and that is measuring the brightness of the objects in the fields of view. And this camera is really, really nice because it has 16 bits per pixel. So that's I can divide, the entire data range, the whole range of intensity where it's sensitive to. I can divide that up into 16,384 pieces, and so my precision in terms of making a measurement of brightness is therefore 1 part in 16,384, and that's not bad, right? Just right out of the bag, 16,384. 1 divided by that times 100. That's 0.006% right there. Now there are lots of other factors that boost that error up, but just in terms of measuring the brightness of things, I can do that 1 part in 16,384. So that's not too bad, to start with. That makes this camera, that's sort of why I specifically chose this camera, was because it did have a nice depth to the bits, right? That's a lot of data values. And that allows me, to measure the brightnesses of these things very, very, very precisely. Um, and that's very, very awesome. So those are the two things that I can do: the astrometry and the um, photometry. Uh, so yeah, what I was working on yesterday was I you know I need to see how well I can do this, and there were sort of two things going on there. The first is that, and you know, I, sometimes I I don't remember things until it sort of tackles me, and then it's like, oh yeah, I remember that. And I had one of those moments yesterday when when I realized that this telescope uh, can indeed only track so well, and yeah, it's not really all that great. So what? But that isn't abnormal. That's normal. Okay, telescopes can only track so well. You're always going to see a little bit of a drift. You're always going to, I mean, it's just that's just how it goes, because these telescopes, um, when you do a um, star alignment, it creates a model, and that model is really only as good as your data. And you know, because because of the fact that they're having to sell these um, um, to the public, that don't have a lot of experience, they sort of have to rely on algorithms that are going to get their tracking and pointing close enough. Um, and it's actually astonishing how well this thing does track, um, for what it's for what data it actually has. It does a really, really good job, really, really awesome job. So I'm really, really impressed with that. But okay, you know, uh, if if but if you only have maybe a 1 second or 2 second exposure before things start to drift a little bit, it's like, what if I wanted to do a 1 hour exposure or a 5 hour exposure? Uh, you know, with the telescope drifting all over the place, there's no way I'm going to have a nice long exposure of anything, because I need to be able to guide on that and track on that really, really, really well. Well, and this is the thing that it's like, you know, once I see it and it's like, oh, okay, oh yeah, I remember that. It's called auto guiding. Auto guiding. And what auto guiding is just this really, really cool way of, um, you can set up a camera to look at a particular field of view of stars. And as long as that camera can see a couple of stars, well, really only one, it really, really needs, you can tell it, okay, I want to keep that star there in the field of view. It doesn't have to be in the center, right? If the star is over here, you just tell it, I want to keep that star right there, okay? And so, and then you start your long exposure, right, on your main um, camera. So you have to have two cameras. You have to have a main camera, and you have to have a camera just for auto guiding. Uh, so you tell the auto guiding camera to, okay, I want you to keep that star right there. And when the star starts to drift due to um, um, tracking um, problems, uh, the software will send a signal to on the telescope to move back or move, in some way in order to keep that star right there. And as long as that star is right there, then the image that you're going to be getting on your main scope is going to be steady. And so you can do a long exposure as long as you want. You can run the auto guider the entire time, and you can do as long as an exposure as you want, right? It's very, very cool, very cool. Um, so that's sort of where I left it last night. Um, Actually night before, day before last. I the the fundamental problem that I had to solve, and I have a solution now. Spoilers, I have a solution. It's not what you expect, but uh, the problem that I had to solve is that I had no way of sending commands from the computer that I used to run the camera and the auto guider. It turns out that this camera, this camera, the SBIG ST7E, okay, actually has two cameras in it. It has the main image camera, and it has its own auto guider camera. Very, very cool. It's its own package. So it can auto guide on stars in the field of view of the main um, camera. So I think that's very, very cool. Makes it super, super easy. But again, the problem that I had is that I had no way of knowing, and I still don't know, what the command protocol is for the scope. Now, on the scope, there is an auto guide slot, right? So it can accept auto guide commands, but I don't know the language. I don't know the interface at all. And the software that I'm using to run the camera is an old version of CCD soft, which is no longer in existence, no longer been developed, is not going to be modified in any way. So I have no way of changing the software in order to allow it to communicate with this telescope. I have no way of doing that. Um, probably I can, but I don't think I'm going to have to. I don't think I'm going to have to, and I can't get into a lot of details about my specific plans. But since they're all related to, making this a science grade instrument, one that can um, collect data that can be published. Um, there's a lot of steps that have to happen um, in order to make that go. And so this whole project is now a go. I thought so. What happened uh, not yesterday but the day before is that I was working on seeing if I could find a way for the auto guider to work, right? To be able to communicate to the telescope, so I could do these long exposures. And whilst I was trying to figure all that out, I installed a piece of software that uh, more or less just messed up everything. So for a while there, last night, um, and into today, into this morning, I had a situation where I could not connect to any camera at all. And if I'm not able to talk to this camera, then I'm not able to get um, um, data, which means I am SOL. And I might as well just uh, you know pack my bags and move on to other things. However, that's not the situation, luckily, because okay, um, so I realized that with this camera, I was having some problems with communications uh, with the camera, and you know, uh, there are sort of two ways to uninstall software. The first is to use Windows. You can go to the control panel and do um, pull up a list of current programs, and you can um, uninstall those. Cheers. Um, some pieces of software have uninstall programs that that you can run, which supposedly clears everything out. Well, it turns out that CCD Soft is one of those programs that leaves residuals. Okay, so when I ran into this problem, not being able to connect to the camera, the first thing I did was erase CCD Soft and reinstalled it. And when I did that, the first thing I noticed is that all my settings hadn't been changed at all. So I had uninstalled everything, okay, which supposedly means wipe clean, right? Did a quote unquote fresh reinstall, and what's supposed to happen at that point is when I run the program again, everything should be set back, to defaults. I should have to choose all my cameras again. I should have to reset all these things. Well, no, everything was already set to what I had previously set them to. So that was a red flag saying, there, something wrong there, something wrong. So uh, most of today, I was messing with that and really not getting anywhere, uh, not getting that far at all. Um, but this whole time, my intuition, right back here, was saying, the registry, the registry, the registry, the registry, the registry, just over and over and over again. Well, as you probably know, the registry is the Windows registry is a very, very complicated place, and you have to be really, really, really careful inside of the registry, because that's sort of, I don't understand what the registry is, what it's for, what it does. I don't have a clue. And so it's like diving into the registry to see if I can clear up a problem. Uh, I mean, a show-stopping problem. If I can't, connect the computer to the camera, I'm done, right? So I have to be able to do that. And the whole time it's like, go to the registry, go to the registry, go to the registry. And so I finally did. I started looking at it. I started searching for keywords, SBIG, CCD soft, all of those. And I did a search, right? I mean, I did a find through the entire registry, just looking for those words. And I did that a few times. So I became a little bit familiar with what things in reference to SBIG, CCD soft. I think CCD Yeah, there was something about CCD ops in there too, which sort of um, um, started this whole mess. So finally, it's like, okay, I think I'm familiar enough with the registry when it comes to these keywords, and those keywords were all over the place, right? All over. Uh, so then it's like, okay, now I'm the uninstall, and I'm going to see what changes, right? I'm going to see in that set of keywords, that I'd found what changes when I try to uninstall this. And so I did the uninstall, and then I looked again a few times at the registry to see what had changed, what had changed. And yeah, I think a couple of things changed, but not much at all. So at this point, okay, I'm like, okay, what I need to do is I need to go into the registry and I need to start deleting things. I need to start deleting things out of the registry. Okay. This is not something that I would recommend doing, especially pretty blind. Okay. Don't really know what the registry is for. I don't know how it relates. Maybe it's like a big index, right? This this shows it just shows all the links and everything. But honestly, it's like I really don't know what I'm doing. and that's and that's not a comfortable position to be in at all. That is not fun. But I did it. Okay. So what I did is I did a search, right? And every single time certain phrases came up, I would delete them. And I went through the whole registry that way on a few keywords. And I deleted every single reference to those keywords. And the whole time I'm just waiting, right, for this machine to stop working, because uh, that's the risk. That's the risk. And it's like, okay, if this machine stops working, then this project is over until I can get some other um, machine that is running, you know, the operating system that this software wants to run on, which is Windows XP, which is great, but it's old software, right? The new stuff won't run on Windows XP. I don't have access to any of the new software anyway. So it's like, okay, I, wait. So I delete all these things out of the registry, okay? And then I reinstall CCD Soft. And that went well. That went well. No problems there at all. And so I run the program and I set, the camera to this and the filter wheel to that. And I set the exposures and all this kind of stuff. And I hit the connect and it says driver not found. It's like, okay. There's another piece of software that's called something like SBIG check drivers. And it comes with the software. So it just does some kind of an update to the drivers. It'll actually go out to the internet and grab the drivers off of SBIG's website and install them on the local machine. So I did that. So I updated all the drivers. I had gone through already and renamed all the drivers um, to something else. And those are all over the place too, right? They're in Windows System 32, they're in program files. They're, everywhere. So I had to go through, and I don't delete things like that unless I really have to. I just rename them. So, that's essentially just, making them invisible. But if I need them, I can always go in and change their name again, and then they're there. So I renamed all these driver files, and then I updated all the, updated all the drivers, downloaded them, updated them, started up CCD Soft again, the camera control software, okay, that talks to the camera, grabs the images, does all that, right? Saves them, the whole shebang, right? Hit the connect button, and see, the problem that I had yesterday was that I needed to, at least I thought I did, I thought I needed to connect to both the main camera and the auto guiding camera. And 2 days ago, 2 nights ago, when I connected, it connected to both of them, right? But after this weird problem, right, I could only connect to one. And if I tried to connect to the other one, I would get can't find driver error of some sort. And then when I tried to connect again, it would just give that same error. I wouldn't be able to reconnect at all, right? So I could connect once, but if I tried to connect both of the cameras, it just it it would fail. So last night I had a situation where it was like, okay, if I need to collect data, then I can do it, and I did that. And if we have some time, I will show you some of the results. You can go on my Discord server and see a few of the results. What? Well, yeah, I'll get into that too. Exactly what I'm trying to do at the moment. But let me finish my story, my long-winded story. The long-winded story is that once I cleared up the registry, once I reinstalled the software, once I updated all the drivers, I hit the connect button, and both of the cameras connected. And it's like, oh, that was great. That was a great moment to have that back. So, the only thing I got back was that I'm right back where I was a couple of days ago. So, but however, that's not exactly true. It's not exactly true because in thinking about this a little bit more, okay, and with the data that I now have, it's pretty amazing. It's pretty amazing. I'm seeing on a moonlit night, okay, with more or less the full moon out, right? Just it was just last night, so it's like 80% full. I am seeing uncalibrated stars down to about magnitude 12 and a half. So on a moonless night, I'm going to see 13 easy. 13th magnitude. You know how there is a lot to do with 13 magnitudes. That's a hell of a lot. It's a hell of a lot. That's a lot of capability. Um, and that's sort of what I was doing last night was oh, the most interesting thing about that is that this is with a 1 second exposure. 1 second on the sky gets me on a moonlit night to magnitude 12.5. I can see 12.5 magnitude stars, uncalibrated data. Okay. Now, what I'm working on now actually is this program called Registax, which I've heard a lot about, and it sounds really, really great. What it does is it um, um, takes, at least this is what I think it does. It takes a series of images Now, these can be like a video, or it can be like a stack of fits images, and that's what I have is fits. Fits stands for Flexible Image Transport System. It's a file format uh, used extensively in astronomy. Um, the format sort of has two parts. It has a text header that has metadata in it. So, the image size, the pixel scale, the exposure time, the date, the time, the position, anything, right? It doesn't matter. You can pack in as much information in there as you want. It's metadata. Metadata is the data that describes data. And the data in this case follows the header, which um, is just a list of numbers, right? The header says how big the image is in both X and Y. So if it's like 100 um, pixels wide and 100 pixels high, then I'm going to have 10,000. Is that right? 10,000. 10,000? Is that 100 by 100? Oh, 100 by 100. I think that's 10,000. Yeah, yeah. It so it's going to have a header, which is just ASCII text, and then after that, it's going to have a list of 10,000 numbers. Now, this could be integers. It could be floating point numbers, but it's a list of 10,000 numbers, and then it's up to the software to format that in a particular way. So that's fits. So Registax can take a stack of fits images and register them, which means, you know, in like one particular image, it may see, like 10 stars, right, in some kind of a pattern. And then because the tracking isn't great on this, the next image will have the same 10 stars in it, but maybe they'll have shifted a little bit. And then the next frame after that will again be the same 10 stars, but moved again. Okay, so because of the problems with the tracking, those 10 stars aren't always in the same place. They're going to drift, they're going to move around because the tracking isn't all that great. Now, if I had an auto guider, then I could have those stars be exactly in the same place every single time. But I'm not going to have that. What I do have is, um, a series of images that have these 10 stars on it, say, on each image. Well, Registax is able to take each of those images and, based on one, it can take the second one, detect sort of where all the stars are, and sort of shift the frame around, and then add those values up. And then it takes the third frame and it shifts them so it matches the pattern. And it'll do this for as many images as you have in the stack. And when you're done, you have this large co-added stack of images that are all properly placed on top of one another. And what that does is it buys you what's called signal to noise. So it'll increase the signal, um, uh, but keep the noise really, really low. So what I expect to see is some pretty nice images coming out of this. I just literally in the last hour, I downloaded Registax. So I'm just, I mean, uh, just moments before I came on here, I was still on it, trying to learn, how to load a stack of FITS images and have it process it. And I think I have it worked out, but I chose 30 images to stack, and that's probably going to take too long. So I'm going to go back, to 2 or 3 or 4, see how long that takes. Hopefully, it won't take as long as 30, and see how well it works. See how well it's able to register and then stack the images up. And I've got pretty high expectations that it's going to look really, really good, really, really nice. So I'm pretty excited about that. Um, and so what that means is, okay, is that, okay, with a 1 second exposure, I can see to magnitude 12 and a half, okay, pretty easily, pretty easily. That's raw data, not calibrated, meaning it's not dark subtracted, it's not flat fielded, it's just raw data coming right out of the camera. It's got all the shit in it, right? All the bad pixels, everything, everything. And I'm getting on a moonlit night, on almost a full moon night, I am seeing the magnitude 12 and a half. I think that is awesome. That is awesome. It's so great being here. This is an incredible asset that yeah, it's going to be very, very exciting. Um, but what I'll be able to do is I'll be able to register and stack these, and um, that will allow me to see even fainter objects. I don't know how much fainter, but when you have a little faint object, but then you add 20 of those, 30 of those on top of one another, that little bump, right, starts to get brighter and brighter and brighter and brighter. So I think that I'm going to be able to see probably past 13th magnitude on a moonlit night, but maybe I'll be able to see 14th. Ooh, I don't know. I don't know. Every magnitude um, in astronomy, magnitude is a measure of brightness, and it's reversed because astronomers, like to do things weird. Cheers. Cheers to weirdness. So every change in one magnitude is actually a factor of 2.5. So a fifth magnitude star is 2.5 times brighter than a sixth magnitude star. See, it goes backwards. The larger the number, the fainter it is. So a 0th magnitude star is 1 magnitude brighter than a first magnitude star. And it's brighter by a factor of 2.5. So every change in magnitude of 1 is actually a change in brightness of 2.5. So what if you have uh, if you have 6 magnitudes to go through, that would be 2.5, well, 2.5 times 2.5 times 2.5 times, that's 3, 2.5, 4, 2.5 times 5, 2.5. So that's, yeah, that's a factor of 244 times brighter or fainter is 5 magnitudes of brightness. So yeah, it's a logarithmic thing. That's just how it goes. So it isn't 2.5 times 6. It's actually 2.5 to the 6th. So that's another way to do it. Is 2.5 to the 6th is 244.14. So yeah. So a 0th magnitude star is 244 times brighter than a 6th magnitude star. And so, see, if I can go from uh, magnitude 12 and a half down to 14 or so, that's a 1.5 magnitude step. So that's 2.5 to the 1.5, which is a factor of 4. It's a factor of 4 uh, fainter. Yeah, significant. That's very, very exciting. So yeah, I need to do. I'm not going to be doing any observing tonight because I've got a lot of data from last night. I took some images around Messier 37. I took some images around M41, M47, and then 2 just sort of random fields. And the cool thing is that this telescope can tell me at least where it thinks it's pointing, and the astrometry program I use, to uh, um, to identify uh, those images in the sky, place them in the sky, um, was good enough to be able, to pick the patterns in the stars out, compare them to star catalogs, and tell me exactly where I was pointed in the sky. And so um, it'll give me, for instance, the right ascension and declination of the center, excuse me, of the center of the field of view. And yeah, very, very awesome. So that's this project is turning out to be really interesting. It turns out I was thinking about it more this afternoon. You know, if I can, even if I was limited to magnitude 12 and a half, that's a lot. That's a lot of capability there. And so, so what that I can't do, hour-long exposures, 2-hour-long exposures. That doesn't, there's a certain, because it's logarithmic, there's a sort of a certain limit where it's like, I'm not gaining very much by doing longer and longer and longer exposures. I'm just not. I calculated it out here, and this isn't this isn't exactly this isn't exactly how this works, but it's pretty close. It's sort of ballpark, back of the envelope type thing. In this case, back of the notebook kind of thing. So if I can do if I can reach magnitude 12 and a half with a 1 second exposure, then that means that I can reach magnitude 13 and a half, right? 1 magnitude fainter with a 2.5 second exposure, right? It's 2.5 times as long as 1 second. If I wanted to get down to 14 and a half, I would have to make a 6.25 second exposure. And then one can extend this down. If I want to get to magnitude 17 and a half, I would have to make a 97.65 second exposure. So that's like a minute and a half or so. And it just gets, worse and worse and worse. There's actually, there's a limitation there, which, can't say as I really know much about. I'm pushing the limits in terms of what I know about imaging. So I'm going to have to find all that kind of stuff out. Um, there is a limiting magnitude in terms of like the brightness of the sky, but yeah, it has to do with signal to noise and all of that. And as the sky gets fainter and fainter and fainter, the signals get lower and lower and lower, sort of, meeting up with the noise. And the sky has a brightness to it. Luckily enough, I'm located in a very, very, very dark place. So the limiting magnitude here is much fainter than in most places, and yeah, that's a great advantage. That's why I'm here, though, is because it's dark. That's the number one reason why I'm at this location in southeastern Arizona, is because it is dark. It is very, very dark. Um, so, but so, you know, I'm not going to be able to do extremely long exposures, 1 second, maybe a second and a half or so, because this thing can only track well on those time scales. So, but even with a 1 second exposure, I can see down to magnitude 12 and a half on a moonlit night. So I have no complaints about that at all. This project is going forward. Uh, as full steam as I can possibly make it. It's going to be really, really interesting. Uh, yeah, I think it's going to be really, really interesting. Can't get into a lot of the details yet, but I will. Now I'm getting into a mode where I need to really push the capabilities of this thing. I need to turn this telescope and this camera into true scientific instruments that can measure positions and can measure brightnesses very accurately and with high precision. Uh, and I'm fully confident that those kinds of things can be done because I've done it before, at least with this camera, and I was using a telescope that was 100 times harder to use than this. The telescope that I used previously did not track at all, so I had to be constantly um, on it to, you know, I get the target in the field of view, and I would let it drift. I'd let it drift across as the Earth turned, and I'd get maybe 6 or 7 um, um, images as it sort of moved across the field of view. These were extremely short exposures because these were very, very bright objects. I was looking at the moons of Jupiter, and so I could use actually uh, like a 50th of a, yeah, like a 50th of a second exposure times, and I get really, really nice signals. Even at that short exposure time, Jupiter was completely overexposed. It was just blasting, blasting. But the moons of Jupiter, which is what I was interested in anyway, uh, came out really, really, really well. And such a short exposure time, even even the rotation of the Earth wasn't fast enough to blur those. So I got nice points. It was really, really great. So the fact that this telescope could track well enough that I can take a 1 second exposure, maybe a second and a half, 2 seconds, and get down to magnitude 12 and a half on a moonlit night, I'm absolutely thrilled, absolutely thrilled. So, and then if I can take like a series of these and add them up and even do better than 12 and a half, I'm anxious, to see how that goes. That's what I'm going to be working on tonight, is getting Registax going. So yeah, very, very cool. There's, as I said, there's a number of things that I still have to do to convince myself that what I have, this guy and my camera, especially this guy, I know the capabilities of the camera already. I got it. This is really one of the best cameras ever made. Um, it's not a large format camera. I think it's something like 750 by 550 pixels, but they're small. They're 9 micron pixels. They're square. And as I said at the beginning, they're 16 bits in depth. And so they have a lot of dynamic range. And that makes it very, very important, to be able to do science. You have to have good dynamic range in order, to get the accuracy really, really well and be very, very precise. So I've got that with the camera. I'm just testing out the scope to see, basically how faint I can go. Now I have to go into a different mode where I'm testing some other things. I've already got a list. I'll definitely be, you know, and I want to share, this whole project with you, and sort of take you along, and let you watch, because that's sort of what this live streaming thing is all about, is uh, watching the lives of others. And we find that fascinating, and hopefully this will be fun, educational, and I'll be able to talk astronomy even more, even more. So, yep, hope everybody's doing good tonight. Hydrogen hydroxide tonight, HOH tonight. Cheers. I never actually looked to see if I was live streaming or not. I'm sure I probably am, but let me go into it and find out if I am or not. Yeah, it looks like I am. Da-dun, da-dun. Yep, I am. Good. So I got to get rid of this. It's starting to drive me insane. Can't handle it. Yeah, it's just, But if this is the only problem that I have to deal with, being a male, I have no problem with that whatsoever. Considering the alternative, no, I'll take this for sure. All right. So that's sort of an update on the progress of the project here. I'm gonna this this system can do photometry, which is the measurement of brightness, and it can do um, 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 astrometry, which is the measure of positions, and lots of possibilities there. Just um, being able to do those two things. There's lots of possibilities there, and there are possibilities that I can't even think of either. So the goal right now is to convince myself that this scope will work well enough uh, to be able to deliver the quality that I need, and so that's sort of the next thing. So what's really, really cool, okay, is that I set myself a 2-week goal uh, by new moon to be in a position where I can sort of move on and worry about seeing if this thing works. My number one uh, concern was that I definitely have to be able to see faint enough in order for things to be um, um, interesting, right? If I could only see down to 5th magnitude or 6th magnitude, that's really limiting. It's really, really limiting. But that's not the fact at all. I can see down to 12.5 on a moonlit night, and should be able to see even fainter when there's no moon at all in the sky. So yeah, that's very, very exciting. And I should be able to see fainter if I stack them as well. And that's with a 1-second exposure, 1 second. So it's very, very cool. So the goal of being in a position to move on uh, I set it, to 2 weeks, and I am finished with that as of today. That was 2 days, people. 2 days. I figured out that I'm good to go in terms of that. I can get the data that I need. Now I need to look at quality. Now I need to look at quality. How well can I focus? Just several things, several things. So, all right, it is just after the hour. It looks like it's 3:01 Coordinated Universal Time. So it's been a good hour. Hope you enjoyed this. As I said, I'm taking you along on the journey, and this is all about astronomy. But it's just I'm going to share with you, the progress of this project as it moves along. As I said, there is an end game, and it's very interesting. Can't say much about it at the moment. Um, Developing still is all I can really say about that. But yeah, I think it's going to be really interesting and very exciting. And let's see, I'm not going to be observing tonight. As I said, as soon as I get off of here, I'm going to get back on to Registax and see if I can stack these images up and see how faint I can go. I've got 30 images of a region around M37, a region around M47, a region around M41, and then two sort of randomly chosen pieces of the sky. The cool thing is that I ran some of these images through um, the site called astrometry.net, and I think I mentioned this all already, uh, which um, which is able, to compute where exactly in the sky this guy is. Well, then I can take that resulting image with all the registration and all of that, and I can import it into Worldwide Telescope. And maybe I'll do that really quick here. Just share my screen, and we can get into Worldwide Telescope. Because with Worldwide Telescope, I can actually import it. This takes a little while to go. We'll just watch the infinity for a while here. Is that cool or what? I don't know why that's there. Yeah, I don't know. Worldwide Telescope sometimes takes a little while to run, especially if other things are running, and obviously other things are running at the moment. So, but we're getting there. We're getting there. Ooh, infinity. I don't know. Whatever it is. Oh, stop. Okay, am I back here? Is it going to pop back? Yeah, okay. So I'm going to share screen again. Worldwide Telescope just came up, so I'll be able to pop into that. Hide that. Sorry, the stream is going to be really slow, but I'm going to go into my collections. And here, oh, did I not save it? I didn't, can't believe it'd be here. No. Oh, that's a bummer. Okay, well, I'm not going to be able to show it off. You can sort of see an example of it on my Discord server. Yeah, I think I put something over there about that. Oh, that's a bummer. For some reason, these things weren't saved. So I'm gonna have to recreate those as well. All right. Well, since that's not going to work, I am going to exit this. I'm going to exit this, and I'm going to blast out of here. Got to I've got to get back up to the ship. Lots to do, lots and lots and lots to do. Lots of cool things, interesting progress. It's pretty freaky deleting things from Windows Registry. That was pretty freaky. Not happy about that. Not happy about that at all. But it had to be done. And in the end, I've got a system, a fully capable system again. So whew, doesn't look like there's an interface between the camera software and talking to the telescope. I'm going to keep researching that a little bit, because if I can do longer exposures with some auto guiding, I definitely want to, but it is not a showstopper at this point. So it's full speed ahead. Yeah, very, very exciting. Okay, I'm going to get out of here for now. Thanks for hanging in. If you're new to this channel, just happened, to fall in, watching this at some future time, make sure to subscribe. You can hit notifications to be told when this is happening every single day. But it is happening every single day, at least at this point, at 2 hours UTC, Coordinated Universal Time. Hit the thumbs up or the thumbs down. I just want a reaction, right? I'm interested, mathematically speaking, I'm interested in the absolute value of the reaction, and not whether it's positive or negative. I just want your reaction. And, if you have anything to say, make some comments. I always enjoy comments, criticisms, anything. I want this thing to get better. I want this to be a big, big, big crowd, because astronomy is cool and it's very fun. It's very interesting, and it's for everybody. And let's see, what else was I going to say about that? I don't know. I don't know. I think I'm going to exit from this planet, get off this planet. For crying out loud, let's get off this planet, right? All right, so I will see you again on the spin. That's the Earth spin, the motion around the sun spin, the motion of the galaxy spin. We are moving about 20 million kilometers every single day. So do you feel it? Do you feel it at all? I don't know. Maybe. Maybe. Hard to tell. All right, I'm going to get out of here for now. Peace. Cheers. And yeah, I will keep you updated on the new project. All right. Bye.